Good morning, iPad Initiative Geometry students from OHS High School. This is your instructor, Mr. Lane, here to do another exciting lesson over proving lines parallel. This is section 3.3, so as always, make sure you get me a half a page of notes with a summary and also answer the number 5 from this page. And let's go ahead and jump into this a little bit here. So we're going to review the angles that we had in the last section. And we're going to be using all those same angles again in this section, except for we're going to be using the converse of what they were in the last section. So we're going to be able to show that lines are parallel given these type of angles are congruent or supplementary. Alright, so the first type of angle here is the corresponding angles. So if we remember, here's our two lines cut by the transversal. The corresponding angles are going to be in the same location of the intersection. So like the upper left on both of them would be examples of corresponding angles. So like angle 1 and angle 5 would be corresponding angles. So let's go on to alternate interior angles. Remember, inside of the two lines cut by the transversal, and then on the opposite side, so like angle 4 and angle 5 would be alternate interior angles. Alternate exterior are going to be on the outside of the two lines and on opposite sides of the transversals. So angle 2 and angle 7 would be examples of alternate exterior angles. And then same side interior are going to be on the same side of the two parallel lines cut by the transversal, and just like it says, on the same side of the transversal. So angle 4 and angle 6 would be examples of same side interior angles. Let's go ahead and move on. Now this first one is a postulate that we had in the last lesson. It says if two parallel lines are cut by transversal, and then the pairs of corresponding angles are congruent. Well, what we're going to do with this lesson is take the converse of that. So we're going to flip-flop the hypothesis with the conclusion, and it's now going to say if two lines are cut by a transversal so that the corresponding angles are congruent, then the lines are parallel. That sounds like a pretty good song. There might be a song at the end of this video. You'll just have to pay attention throughout the whole thing and see if it happens to be there. I'm not saying if I'm dancing in the video. You'll just have to wait and get there on your own. Let's move on real quick here. We've got the converse of the corresponding angles postulate that we're going to use with the given information to show that L is parallel with M. So we have the measure of angle 2 equals the measure of angle 6. I'm just going to highlight that for us right here in the diagram. And if those two angles have the same measure, then that would mean, by the definition of congruent angles, that angle 2 would be congruent with angle 6. And if those two are congruent and they're corresponding angles, then by the converse of the corresponding angles postulate, then this would have to be my L, this would be my M. I'd be able to say then that L is parallel with M. So all we did was use two things: definition of congruent angles and then the converse of the corresponding angles postulate. Let's move on. Another type of problem that we can do with these is we can set them up where we can find a value of x that would make M and N parallel to each other. So we're just going to solve this one real quick. Notice that they're corresponding angles, so if these two lines would be parallel, then these two angles would have to be congruent. So I'm going to put 3x plus 5 equals 65. So it looks like to solve this I'll have to subtract 5, and that would be 60. Cross those out here. 3x equals 60 then. So if I divide by 3 on both sides, and it looks like x would have to be 20. So x equals 20 would make these two corresponding angles congruent, which would in turn make M parallel with N. If X was any other value besides 20, then M and N would not be parallel. Alright, the regular class would be doing 2, 12, and 14 from page 166 at this time. As always, the iPad Initiative students, your lesson or homework questions are attached to the lesson. That didn't quite come out right. Alright, on this page I went out there and I found the converse of the next types of angles already out there on the internet, so I just copied and pasted it here. Make sure you get these in your notes, but they're all going to sound really similar to one another. It's going to say if two lines are cut by a transversal so that the alternate interior angles are congruent, then the lines are parallel. That would almost make a great song. If the two lines are cut by a transversal so that the alternate exterior angles are congruent, then the lines are parallel. And again, on the last one down here now, they call it the consecutive interior angles. It's same side interior angles for us, but it says if two lines are cut by transversal so that the same side interior angles are supplementary, remember they're not congruent, they're just supplementary, then the lines are parallel. I wonder if it'd be a country or a hip-hop song, I'm not sure. Alright, let's move on here. To use this information, we're going to use the diagram below with the given information to show that R and S are parallel. On this, I think I've messed up a little bit. I think this is supposed to be the measure of angle 5 on this page here. So I'm going to have the measure of angle 4 equals the measure of angle 5. So what type of angles would those two be? Well, hopefully you recognize that as on the outside of my two lines cut by the transversal and on opposite sides of the transversal. So that's going to make those alternate exterior angles. So if their measures are the same, then I could say that angle 4 is congruent to angle 5 by definition of congruent angles, just meaning that their measures are equal. And then by the converse of the alternate exterior angles theorem, line R would have to be parallel to line S. So that's how we'd use that diagram, that information, to show that those two lines are parallel. And again, they're going to make the same type of questions that they did before on finding an X value, so that it makes the two lines parallel. So notice that these two would have to be congruent. So I would put 2x would have to equal x. So I think the only way to solve this is what? Subtract my x here, subtract it here, and it looks like x would have to equal 0. Yep. So the only x value that would make that true to make M and L parallel, or M and N parallel, would have to be the x value of 0. Alright, regular geometry students would be doing 4, 6, 8, 16, 18, and 20 from page 166. We're going to keep trucking along here. We're going to be given that angle 1 is congruent to angle 4, and angle 3, I think I've got a little typo right here. I'm going to take care of that real quick. And angle 3 and angle 4 are supplementary, and we're going to have to prove that L is parallel to M. So let's mark down here in the diagram what we've got. We're going to have 1, let's mark that in red, maybe we can see it a little bit better. 1 and 4 are congruent, so what information or what type of angles are those? Those would be alternate, just going to make a quick note of it here, interior angles. Okay, and then let's see, angle 3 and angle 4 are supplementary. So let's see if I can maybe mark this in blue here. These two would be same side interior angles. Alright, so let's see, L and M. I see an R, an M, and an N. So I'm going to pause this real quick and fix that. Alright, so the R should have been labeled as an L, and that was the problem with the diagram there. So we're going to go ahead and continue on here. We're just going to write this out kind of a paragraph proof style here. Let's see, by angle 1 being congruent to angle 4, we can use the converse of the what do we write? Alternate interior angles theorem to show that would make L parallel to N, and then also by angle 3 and angle 4 supplementary, we can use the same side interior angles theorem to show M is parallel to N, and then thus with L, where's my L, parallel to N, and M parallel to N, then the two lines must be congruent to each other. And that would be kind of a paragraph proof style format for that one. Alright, let's move on here. Let's see, this is another example. Is there enough information to prove that lines A and B are parallel? So right here, if I've got these two lines cut by a transversal, that's alternate exterior angles and they're marked congruent. So therefore, yes, there would be enough to prove those lines parallel. Then on this next one here, we've got corresponding angles, same type of thing, but by the converse of the corresponding angles postulate, those two lines would be parallel. And then it says that angle 1 and angle 2 adds up to equal 180. Well, notice that those aren't same side interior angles, so I'm going to say there's no way to prove that those two lines would be parallel just by that given information. So I think that's going to wrap us up real quick here. I'm going to pause. Alright, last few minutes here. I'm going to play a little bit of that song that I've recorded here for you. I'm also going to just attach it as a separate video if you do want to watch that. So we're going to end this video, listen to a little bit of it. Yeah, it doesn't get much better. Mr. Lane signing off from OHS. Catch you next time.